So hello everyone, I'm back with another video. So in this video, we are going to talk about the searching and the ranking phase. So before starting this phase, I just want to show you guys the output of the TF-IDF calculation that we did in the previous video. I'm so sorry guys, I forgot to show you guys the output. So we are going to see it here. I've just run the script that will run TF-IDF calculation. So I have printed results for three different documents that are totally random. That is the document 0, document 5 and document 6. So in document 0, we have all the tokens from document 0 and we have all the scores that we have discussed previously. That means we have to calculate the TF-IDF score for each and every terms of each and every document. So these are the different terms in document 0, 5 and 6 and they are arranged in descending order. The term with higher TF-IDF score is shown first. So now let's continue our searching and ranking phase. So in this phase, there are some steps that are involved that are very important. Firstly, we need to take the user query and preprocess it like the same way we did it for every other documents. That is, we need to convert everything into the lowercase. We need to remove different symbols, punctuations. We need to remove every stopwatch. We need to stem the document, that is, or the query. We just need to run that simple stemmer that we have wrote in the first video, and lastly we just need to tokenize the whole string. And the second point is we need to compare the query term with the document's TF-IDF score. So you have TF-IDF score for each and every tokens of each and every document. So what in this phase, what we need to do is we will take the query, we'll get the tokens. Now we have to check if the token is present in any of the documents or not. So we have to check first. Okay, if there is present, then we are just going to get the TF-IDF score and add them all for each document. The fourth is rank the document. So we have to rank the document on the basis of that cumulative sum of TF-IDF score that we got after comparing the query and the document's tokens TF-IDF value. And the fifth thing is we just need to display the most relevant documents, like rank them, and we can display k number of relevant documents. So first thing, this phase, it gives the result in this format. So this is the result format. So what we can see is we have this list which consists of document ID and the relevant score. So relevant score we get using our cumulative sum of each and every tokens that are present in the document after comparing the query with the document. So it's all on the basis of TF-IDF scores. We can display the k values. So this is the result structure. And firstly, we need to initialize the score for each and every document 0 firstly, so that we can add each time we get the term with respect to the query. So after comparison of the query and the term, we can get the tokens TF-IDF value that we can add, so that we can compute the relevant score on the basis of sum of each and every TF-IDF values of the tokens that are present in the query. So on the basis of that, we can just rank the documents, and after the completion of searching and ranking phase, we will get some score for each and every documents, like let's suppose 0.7 or anything. So, and here we can see 0.1. So in this case, document 0 is the one having the most or the highest relevant score. So it is given as the result to the user for that query that is given by the user. The user's query has the most relevance with this document, that is document 0. Just an example. And the search and compare. So what we can do is we can run a real life example. Let's take this query, machine learning algorithm. So if I am the user, I will just search machine learning algorithm and I hope that I get some result. So the result is basically the documents that is relevant with this query. So firstly, what we can do is okay, let's copy this down. Okay, so first step, we need to pre-process the query that we have already discussed here. So what we will get is the tokens are, one is machine, another is learn after applying simple stemming, and the another is algorithm. So now we have already got the tokens from the query. So the first step, what we need to do is we need to compare the query term with documents tokens TF-IDF values. So first thing, let's search for each and every tokens in in the document and compare it with the query tokens. So firstly, let's search for machine one by one every document. So machine, I have here one machine and 2 and 3. Okay, machine is completed. Now let's talk about learn. Okay, we have here learn. So here is learn. Okay, so okay, learn here, learn here, learn here, learn here. Okay, this much. Learn. Okay, double check, guys. Now we have to compare this query token algorithm with the tokens that are present in our documents. So algorithm, okay, here is one, here is another. Algorithm. I don't see anyone. Okay, so for 0 and 1, 0, okay, 2, 0, 1, 2, 3, 4, 5. So 5, and this is 6, and this is 7. Oh, okay. Now we have to compute the relevant score for these documents. Document 0, 2, 5, 6, and 7. So what we can do is for document 0, one is machine, the second is learn, and the third is algorithm. So let's write down the TF-IDF score from the previous from the program that we have run just now. Okay, we should get the TF-IDF score for each and every documents of each and every tokens. So let's see. For document 0, we have machine. Machine has okay 0.214, 0.1204. We are comparing from this table. For relevance score, you just have to add everything. So let's add this. So we have just add them all, and we have calculated the relevance score for each and every document. Now the only thing we have to do is sort them. So first, this will be first. Okay, this will be second, this will be third, or this will be fourth, anything, same value, and this will be 5. So if we are giving the five most relevant searches result, then we will have the result according to this. So document 0 will be the first, and then the document 6, and then the document 2 or 5, and then document 7. So for this, we can also verify by reviewing our code that we have written. So let's see that. So this is the code that we have written. So if we see and interpret each and every line of code, we will get the same kind of result, I hope. Let's see. So firstly, we will call the build in inverted index, and we will call calculate tf-idf that we have already done, and now we will add to like process query. So in process query function, we take the query, we take the tf-idf table and the documents. First thing, we need to pre-process the text. We have done it. We got these tokens, and calculate the relevance score. So this is the relevance score that we were talking about. So for document 0, it can be, so for document 0 it's like this. So it's like a dictionary that has the key integer, and the value is the relevance score. And what we are doing is we are going through each and every documents, and we are just going through each and every tokens of the documents. And what we are doing is, from tf-idf table, we are getting the score, and we are just adding them all. So in this loop, we are doing the same thing. So relevance score on the basis of document ID is the score, and the score is nothing but the sum of each and every tf-idf of each and every tokens that are relevant with the query, or that is similar to that of query tokens. Here we are just sorting that we did here, just sorting on the basis of the relevance score. Let's run this and see if our code is working or not, because we have manually already calculated each and everything. So it should match with the result that we get after running this code. I've done for multiple queries. So I think, so in this example, I think I have used the first one. Yeah, the query first one I have used machine learning algorithm. So I should get document 0 first, yes, and document 6 and document 5 are 2, because they have the same score. So we are getting the same thing. Yeah, yes. So the score is also matching. Our code is running okay. So I have processed many queries, but we have just taken the example of one. This series was a success because we got the end result. So now after this 4 video, we have come to the conclusion, and we have solved this searching and indexing problem. For this series, this is the final video, and I will be back with similar kind of videos. So for this series, this much. Thank you for watching my video. If you guys like the video, you can give a thumbs up, and if you really like the video, you can subscribe. And bye until the next time.